Hello, today's video will be about zeros and multiplicity. So zeros are the point at which the function intersects the x-axis. And a polynomial function of degree n can have at most n real roots, meaning the degree is something that we're going to learn means the highest exponent in a function. So if we have x cubed plus x squared, plus x plus 5, 3 is the highest exponent, and therefore the degree would be 3, and at most that function could have 3 real zeros. An even degree polynomial has an even number of zeros or no zeros at all. And an odd degree polynomial has an odd number of zeros. So to identify zeros by graphing, we're going to rely on our graphing calculator a lot. So let's move over to there. All right, so on your calculator, we will go to the y equals screen in the top left, and we'll type in our equation. So x to the third plus x squared minus 2x. And then hit graph just to get a general idea of what the graph looks like. So if we recall that zeros are the places where the graph touches the x-axis, we're going to see that our graph has 1, 2, 3 zeros. So we are going to go to the table and find the value of those 3 zeros. And those are going to be where the y column has zeros in it. So 0, 0, 0. Those are our 3 zeros. And the answers, or the solutions, are the x value where the equation equals 0. So for the graph, I'm only concerned about you plotting these 3 points. And then the rest of it can just be a rough sketch from the picture that we have. So from the table, we saw that our zeros are going to be at -2, 0, and +1. And then if we're looking at this sketch of the graph, we can make a rough sketch of that on our graph. And so we have this graph, and then the way that we write our solutions is x equals the solution set of -2, 0, and 1. So this is our answer, our final answer. So I would suggest that you try this one on your own just to get a little bit of practice, but I'm going to go ahead and continue. So pause this and do it on your own if you'd like. You should find that your zeros will be at -1, -1, +1, and +3. And your graph should make kind of an M shape. It's not exact, but close enough. So the solution set is x equals -1, 1, 3. So another way to find the zeros of a function are by finding its linear factors. And we do that by writing an equation in factored form. So factoring should be a review, but to factor this function, we're going to first take out an x because that's the greatest common factor. Then we can factor this trinomial into 2 binomials. Since this x squared has no coefficient, we just start with x and x. And then we want 2 numbers that multiply to get -15 and add to get -2. That's going to be -5 and +3. Then we set each factor equal to 0. Now we're going to solve for each x value. This one is already solved. This one will give us x equals +5. This one will give us x equals -3. So the solution set is x equals -3, 0, 5. I usually write them in order from least to greatest. Now let's talk about multiplicity. The multiplicity of a 0 is equal to the number of times its corresponding linear factor occurs. So let's factor this new equation. We're going to take an x out again. We get x squared minus 6x plus 9. And then we factor that into two binomials. This time we're going to get -3 and -3. So this shows up twice. We could also write this as x times x minus 3 squared. So then we set each factor equal to 0. So x equals 0 and x minus 3 equals 0, or x equals +3. Now, x equals 0 corresponds with this factor. And it only shows up once in our equation. So this has a multiplicity of 1. X equals 3 corresponds with this factor, or these two factors. And as you can see, it shows up twice in our function, so it has a multiplicity of 2. So down here, we're going to have x equals 0, multiplicity of 1, and x equals 3 with a multiplicity of 2. So this problem uses the exact same equation as number 4 did, and we're just going to look at the graph of this equation now. So if we graph it, there is a 0 at 0, and there's one at +3. And if you'll notice, it goes through the x-axis here, and here it bounces off the x-axis and goes back up. So something that this tells us, we had x equals 0 with a multiplicity of 1, and x equals 3 with a multiplicity of 2. If the multiplicity is odd, then the graph will cross the x-axis at that 0. If the multiplicity is even, then the graph bounces at that 0. It bounces off the x-axis. All right, so for number 6, this one is already factored for us, so we're just going to start by setting each one equal to 0. So we're going to get x plus 7 equals 0, which is x equals -7. 2x plus 1 equals 0, which gives us x equals -1/2. And x minus 4 equals 0 gives us x equals 4. So we have -7, -1/2, and +4. The multiplicity of -7 is this exponent, 2. The multiplicity of -1/2, there's no exponent here, so it's understood to be a 1. And then the multiplicity of 4 is going to be 3. So since 2 is even, it will bounce. Since 1 is odd, it will cross. Since 3 is odd, it will cross. For number 7, I would encourage you to try this one on your own. Press pause and then come back and check your answers. We'll start by factoring this one. We'll have to take out an x squared. That'll leave us with x squared minus 2x minus 8. Then we will factor that one more time. We're going to get -4 plus 2. So we're going to get x equals 0, x equals 4, and x equals -2. 0, 4, -2. 0 has a multiplicity of 2. 4 has a multiplicity of 1, and -2 has a multiplicity of 1. So this is going to bounce, and the other two will cross. And finally, a word problem. A polynomial function has a 0 at -6 with a multiplicity of 2 and at 2 with a multiplicity of 1. Write a polynomial function in standard form that could represent this function. So if we know that our answer, our 0, has to be at x equals -6. So in a binomial, when we set it equal to 0, gives us an answer of -6. That's going to have to be x plus 6. And it has a multiplicity of 2, so it's going to be squared. To get an answer of 2, we would have to have the binomial x minus 2. It has a multiplicity of 1, so it does not need an exponent. So what we're going to do is we need to multiply x plus 6 times x plus 6 times x minus 2. I'm going to start by multiplying these two together. First, I distribute the x to the x plus 6. So we'll get x squared plus 6x, and then we'll distribute the 6 plus 6x plus 36. Now, all of this has to stay in parentheses until we multiply it by x minus 2. I'm going to combine like terms though, so there are fewer terms to multiply. And we get x squared plus 12x plus 36 times x minus 2. Now, my preference is to kind of distribute backwards, just because then you have to distribute fewer things. So I'm going to distribute the x to these three terms, then I'm going to distribute -2 to these three terms. So x cubed plus 12x squared plus 36x minus 2x squared minus 24x minus 72. So then I'm going to combine like terms. This one is x cubed, x squared, x squared, x, and 72. Okay, so this just helps me see which ones are actually like terms and easier to combine. So I'm going to start with x cubed. 12x squared minus 2x squared is 10x squared. 36x minus 24x is positive 12x. And then negative 72. And this is our polynomial in standard form that could have these zeros. That's all for today. Thank you for listening.